So let us discuss another problem. So here a bowling machine projects a ball of mass 0.15 kg in upward direction. If a ball is displaced along bowling machine 0.2 meters and released, after released from bowling machine, ball attain 20-meter height, then find the force exerted by bowling machine on the ball. Force exerted by the bowling machine on the ball. Okay. So here this is a bowling machine. Okay. Now the ball is compressed up to 0.2 meters and released. The ball attains a height 20 meters. So the ball attains a height 20 meters. Okay. Ball is compressed from this point to this point 0.2 meters and released. The ball is attain height 20 meters. Here the machine force is acting up to 0.2 meters. 0.2 meters. Here to here, here to here, the machine force is acting. Once the ball reaches to height 20 meters, once the ball leaves the contact of the machine, then there is a gravitational force is acting. So here initial kinetic energy is 0. Here initial kinetic energy is 0. Final kinetic energy also 0. Final kinetic energy also 0. So from work energy theorem, work done by gravitational force plus work done by machine force is equal to change in kinetic energy. There is no change in kinetic energy. Work done by gravitational force. Work done by gravitation negative. The ball is raising upward, gravitational force is acting downward. That is equal to minus mg h. The ball raises from this point to this point. So total height is equal to how much? 20 plus 0.2. 20.2. Okay. Plus work done by machine force. Force into displacement. What is the displacement of a ball here? 0.2 meters. Is equal to 0. Right. Here G value is 10. 0.15 into G value 10 into 20.2 is equal to minus F into 0.2. Minus F into 0.2. Right. We want to find out F. So F is equal to 0.15 into 10 into 20.2 divided by 0.2. Divided by 0.2. So that is equal to 1.5. 10 into 0.15. 1.5. 10 into 20.2. That is equal to 202. 202. Okay. That is equal to here 10 into 0.15 1.5. This 0.2 written as 2 by 10, that is equal to 202 divided by 2. This is 2 ones are 2 zeros, 2 ones are. Okay. Finally, we get what answer? We get 151.5 newtons. By multiplying 1.5 into 101, we get answer 151.5 newtons. A man of mass 80 kg is standing on a circumference of a disc of mass 200 kg. Okay. Disc is rotating about the vertical axis with angular speed of 5 revolutions per second. Find the angular speed of disc if man reaches at the center of disc. So, this is a disc. Now, this disc is rotating about diameter, about vertical axis. Here a man is standing at the circumference of the disc. So, this is the radius of disc. Now, we want to find out find the angular speed of disc if man is reaches at the center of disc. Man is reaches at the center of the disc. Right. Here mass of man m1 is equal to how much here? 80 kg. Okay. Mass of disc m2 is equal to 200 kg. 200 kg. Right. Man is rotating with angular speed omega 1 is equal to 5 revolutions per second. Find the angular speed of disc if man reaches at the center of disc. Omega 2 is equal to question mark. Right. Here the force between disc and man is internal force. So, there is no torque acting on the system. No torque acting on this one. 0. The angular moment of system is conserved. Now, I1 omega 1 is equal to I2 omega 2. I1 omega 1 is equal to I2 omega 2. Right. Initial angular moment. Initially, the man is standing at the edge of the disc. So, his moment of inertia. Here, the moment of inertia I1 is equal to moment of inertia of a man m1 r square plus moment of inertia of a disc about diameter is equal to m2 r square by 2 into omega 1. Omega 1. Omega 1 is nothing but 5 is equal to I2. When man reaches from this point to this point, his moment of inertia is 0. His moment of inertia is 0. Why? Because R is 0. So, 0 plus moment of inertia of a disc about diameter, that is equal to m2 r square by 2 into omega 2 into omega 2. Right. m1 80. Okay. here r square taken common, r square cancel, plus m2 200 by 2 into 5 is equal to 200 by 2 into omega 2. So 80 plus 100 into 5 is equal to 100 into omega 2. 100 into omega 2. Right. Here this is 180 into 5 is equal to 100 into omega 2. Omega 2 is equal to 180 into 5 divided by 100. 0 0 cancel. That is equal to 90 by 10. That is equal to 9 revolutions per second. 9 revolutions per second. This is our answer. This is our answer. 9 revolutions per second. Now let us discuss another question. Here magnetic field at the center of hexagon coil having 50 turns, side 10 centimeters and current I in terms of mu naught I by pi will be. Mu naught I by pi will be. Okay. So the current is flowing in this regular hexagon along this direction. This is I. We know that a regular hexagon is the combination of equal triangles. So this is 10 centimeter side, 10 centimeter. Now we want to find out magnetic field at the center of the regular hexagon. Regular hexagon. So first we want to find out due to one conductor, then multiply that magnetic field with the remaining conductors. So here what is the direction of this magnetic field at the center? Into the paper, into the paper. So this is 60 degrees, this also 60 degrees, and this angle 30, and this angle 30. We know that formula to find out the magnetic field at the center of the coil, B equal to mu naught I by 4 pi r, mu naught I by 4 pi r cos alpha plus cos beta. If we take these angles, we write cos alpha plus cos beta. If we take these angles, we write sin alpha plus sin beta, or you may be written as mu naught by 4 pi r sin alpha plus sin beta. If we take 30 30, then alpha is equal 30, beta is equal 30. If we take 60 60, alpha is equal 60, beta is equal 60. Right. You can do in any model. Mu naught I by, due to this conductor. First we want to find out the magnetic field due to this conductor at the center. Mu naught by 4 pi. This is equal triangle. Okay. Now this we want to find out this r. So in equal triangle, the altitude is root 3 by 2 times of length of the side. That means r is equal to, we write directly without doing any calculation, root 3 by 2 into 10. R is equal to 5 root 3 centimeters. 5 root 3 centimeters. So this is about 5 root 3 centimeters. Right. Now 4 pi into r, that is equal to 5 root 3 centimeters 10 to the power of minus 2 cos 60 plus cos 60. Cos 60 plus cos 60. Right. B is equal to mu naught I bring this 10 to the power of minus 2 to the numerator, 10 square divided by 20 root 3 pi, 1 by 2 plus 1 by 2. So B is equal to mu naught I, this is 100, this is 25 pi, root 3 pi, 1 by 2 plus 1 by 2, 1. Okay. Now we want to find out, this is a magnetic field due to only one conductor. Now we want to find out a magnetic field due to all conductors. This is hexagon, so you should multiply this B with 6. B due to all sides is equal to B net is equal to 5 into mu naught I into 5. This is 6. This is 6. 6 into mu naught I by 5 by root 3 pi. Root 3 pi. Right. Here, how many number of turns are there here? The number of turns are 50. Now you should multiply with 50. That is equal to, what we get here, 6 into 5, 30 into 50, 1500 mu naught I divided by root 3 pi. Right. Here now multiply this fraction with root 3 and divide it with root 3. Then what we get here, 500 root 3 divided by pi. Root 3 into root 3, 3. 3 cancel in 1500, 500 times, 500 root 3 I by pi. So this is the total magnetic induction at the center of the regular hexagon. Now let us discuss another important question. Here, first of all, read this problem. The hollow cylinder of length L and inner and outer radius are R1 and R2. Find the resistance of the cylinder if current flows radially outward in the cylinder. The resistivity of the material of the cylinder is rho. Okay, what type of cylinder it is? It is hollow cylinder. So hollow cylinder. Okay. Is this hollow cylinder outer radius? Outer radius is R1. Outer radius is equal to how much? Sorry, R2. Inner radius is nothing but how much? R1. Inner radius is nothing but R1. Find the resistance of the cylinder if the current flows radially outward. Radially outward. The current flows radially outward. Resistivity of the material of the cylinder is rho. So whenever the current is flowing radially outward along this direction, here area of the cylinder gradually increases. As radius increases, area of the cylinder also changes. When the current flowing along this direction, radius increases, so that area changes, but length constant. So, to solve this problem, we consider a small element of thickness dx, a small element of thickness dx. Small element of thickness dx, whose length is nothing but how much? L, whose length is L. Right. Now, this small element resistance is dr. This dr is equal to rho into length of this small element dx. A, that means area of this small element. So, here this small element is at a distance x from the center of the cylinder. So, area is nothing but 2 pi RL, 2 pi XL. Right. To find out the resistance of the cylinder, we have to integrate this dr from R1 to R2. dr from R1 to R2 is equal to R1 to R2 rho into dx divided by 2 pi into XL. Right. Now, R is equal to rho constant, rho by 2 pi L constant here, integration of R1 to R2, we have to write dx by x. So, here R is equal to rho by 2 pi L, here log x, limits is R1 R2. Integration of dx by x is equal to how much? Log x. So, R is equal to rho by 2 pi L log R2 minus log R1. Okay. After doing after completed integration, x is replaced by R2 upper limit and x is replaced by lower limit. R is equal to rho by 2 pi L here log R2 pi R1. So, this is the resistance of the hollow cylinder. Resistance of the hollow cylinder. So, in Young double slit experiment, wavelength of light used is 500 nanometers and the slit width is 0.05 millimeters. Then angular fringe width will be here. Wavelength of light is used 500 nanometers. Okay, slit width is nothing but 0.05 millimeters. That is equal to, here 500 nanometers is equal to 500 into 10 to the power of minus 9 meters, 0.05 into 10 to the power of minus 3 meters. Fringe width, theta is equal to lambda by d. Formula 500 into 10 to the power of minus 9 divided by 0.05 into 10 to the power of minus 3. Okay. Right. Here this can be written as 5 into 10 to the power of minus 7 divided by 5 into 10 to the power of minus 5. That is equal to, this is 1 by 10 square, that is equal to 1 by 100. 1 by 100. Now, angular fringe width is given in radians, in degrees. We know that here pi radian is equal to 180 degree. So 1 degree is equal to how much? 180 by pi. One radian is equal to 180 by pi degrees. Right. 1 radian. Here answer is comes in radians. Now we should convert it into degrees. That is equal to theta is equal to here 1 by 100 into 180 by pi. Okay, this is radians. Okay. So 1 by 100 into 180 by pi. So theta is equal to 0 0 cancel, 2 9s are 2 5s are. That is equal to 9 by 5 pi. 9 by 5 pi. That is equal to 9 by 5 into 22 by 7. 63 divided by 110. So theta is equal to how much here? Theta is equal to here so by doing calculation we get 0.57 degrees. 0.57 degrees. Our answer is 0.57 degrees. Okay, next question. A radioactive sample remains undecayed 9 by 16 after time t. Okay, how much sample remains undecayed after time t by 2? After time t by 2. Right. Here at t is equal to 0. T is equal to 0. Initially, the radioactive sample remains is n naught. Remains is n naught. That t is equal to t of what happens? The fraction of radioactive sample remains is equal to how much fraction of radioactive sample remains? Let us assume that f fraction of radioactive sample remains, f into n naught, f into n naught. At t is equal to t of the fraction of radioactive sample remains is equal to again f fraction. That means f fraction of radioactive sample at t is equal to t of, that is equal to f square into n naught, f square into n naught. So according to here at t is equal to t. Why? Because of every half time a fraction of radioactive sample remains. But according to problem, what they given here, they given 9 by 16, 9 by 16 fraction of initial radioactive substance remains, f square into n naught. N naught and naught cancel, f square is equal to 9 by 16, f is equal to 3 by 4. So our answer is 3 by 4. 3/4 fraction is remains after time t. After time t seconds. So here in this question, EM wave is given by b bar is equal to 3 into 10 to the power of minus 8 sin ky plus omega t into I. Find E bar. Find electric wave. We know that electromagnetic wave is nothing but what? It is the combination of electric wave and magnetic wave. Both are traveling in perpendicular directions. Right. Here wave is propagating along a negative y direction. So this is magnetic wave along a positive x-axis I. Now the wave is propagating along minus y direction, negative y-axis direction, negative y-axis direction. Right. We know that E bar cross B bar is the direction of E bar cross B bar is parallel to C bar. So this is here B bar direction is I, that is equal to minus j. C bar, what is the direction of propagation of electromagnetic wave? Along minus y direction. Okay. The direction of propagation of EM wave in the direction of E bar cross B bar. So here the direction of the direction of propagation of electromagnetic wave is along the direction of E bar cross B bar. Right. And that electromagnetic wave direction is both perpendicular to E bar and B bar. Here, what is the direction of E bar? Here, definitely we say that is minus k. Minus k direction. K cross I, minus k cross I is equal to minus a. That means this is E bar cross B bar parallel to C cap. This condition is satisfied whenever the direction of E bar is minus k cap. So here we conclude that direction of E bar is along minus k cap direction. Minus k cap direction is along minus k cap direction. So here we calculate magnitude of E by using the formula E is equal to C into B naught. Okay. So in a given volume of a solid cylinder, find the ratio of L by R such that moment of inertia of a cylinder about an axis O dash will be maximum. Right. To solve this problem, moment of inertia of a cylinder about an axis O dash is equal to I is equal to ml square by 12 plus mr square by 4. So here the moment of inertia of a cylinder about axis O dash will be maximum. That means di by dl, its derivative is 0. Its derivative is 0. We know that V is equal to pi r square L, volume of the cylinder. R square is equal to V by pi L. Substitute this value in this equation. So di by dl is equal to m into L square derivation 2L by 12 plus m into R square is equal to V by pi L divided by 4. What is the derivation of 1 by L minus 1 by L square? Minus 1 by L square. So here m into 2L by 12 is equal to minus m into V by 4 pi L square. Get cancelled. Okay. Now we find out here minus cancel. So V is equal to what we get here 2L into 4 pi L square divided by 12. That is equal to 2 by 3 pi L cube. 2 by 3 pi L cube. V is equal to 2 by 3 pi L cube. Here. Okay, right. But what is V here? V is equal to pi r square L. So pi r square L is equal to, here V is equal to how much? 2 by 3 pi L cube. 2 by 3 pi L cube. Now pi cancel. This L cancel in L square times. Now L square by R square is equal to 3 by 2. L by R is equal to square root of 3 by 2. Square root of 3 by 2. Energy of electron in its nth orbit is given as En is equal to minus 13.6 by n square into z square electron volt. Consider a hydrogen atom. Find the amount of energy needed to transfer electron from first orbit to third orbit. First orbit to third orbit. This is very basic question. Right. Energy of electron in first orbit E1 is equal to, here put n is equal to 1 and this is hydrogen atom, z is equal to 1. We get minus 13.6 electron volt. Okay. Energy of electron in third orbit. E3 is equal to, what we get here, minus 13.6 by 9, that is equal to minus 1.5 electron volts. Minus 1.5 electron volts. Right. Now the difference in these energy levels is equal to energy needed to transfer electron from first orbit to third orbit. The difference in energy levels the difference in energy levels. So what we get here, the difference in energy levels means minus 1.5 minus E3 minus E1, that is equal to minus 1.5 plus 13.6, that is equal to 12.1 electron volts. 12.1 electron volts. This is our answer. So here another problem is, an external pressure P is applied on a cube at 273 Kelvin. Hence, it compresses equally from all sides. Alpha is the quotient of linear expansion and K is bulk modulus of a material. To bring the cube to its original size by heat, the temperature raise must be. How much temperature it raises? This is the problem. Okay. Let us assume this is a cube. Whenever this cube is compresses equally in all directions, it compresses. Alpha is the quotient of linear expansion. So, whenever it is heated, then how much compression takes place? Same expansion also takes place when the cube is heated. Now, bulk modulus K is equal to, we wrote that what is bulk modulus? Bulk stress by bulk strain, F by A by delta V by B. So volume decreases, pressure increases. Okay. So here that is equal to minus P by delta V by V. So K is equal to minus PV by delta V. We know that here we know that gamma is equal to delta V by V into delta T. Delta T is equal to delta V by V into gamma. Okay. So here delta V by V. So here this is equation 2 and this is equation 1, right? From 1, what we write here, delta V by V is equal to P by K. P by K. So here delta T is equal to what we write here, delta V by V is equal to P by K. P by K into gamma. P by K into gamma. So here delta T is equal to, finally we write P by K into, what is gamma here? Gamma is equal to 3 alpha. So our answer is delta T is equal to P by K into 3 alpha. This is the rise in temperature. Okay. Next problem. In LCR circuit, as shown figure, due to heat developed in T seconds, temperature of resistance is increased by 10 degrees centigrade. Okay. If heat capacity of a resistance of a material is 100 joules per degree centigrade, then calculate the value of T. whenever the current is passing through resistance, heat is developed. Due to that heat, temperature is increases by 10 degrees centigrade. Okay, then what is the value of T? Here we know that E is equal to general equation E0 sine 100 pi T plus pi by 2. Okay, so here E0 is equal to how much? 25. E0 is equal to 25. Right. I0 is equal to E0 by Z. So Z is equal here LCR circuit square root of R square plus XL minus XC whole square. So Z is equal to R square and 4 square plus XL minus XC. This is inductive reactance. Inductive reactance 7 minus 4 whole square. So that is equal to how much here? 4 square plus 3 square. That is equal to root 25. That is equal to 5. That is equal to 5. Now heat developed. Heat developed is equal to, we write that I square RT. That means IRMS square RT. So heat developed means how much heat developed here? Heat developed, that is equal to MS delta T is equal to IRMS square into RT. MS, heat capacity. Here heat capacity is equal to how much? Heat capacity 100 joules per degree centigrade. Delta T is equal to how much? 10 degrees centigrade. So here 100 into 10, that is equal to IRMS square means I0 by root 2, that is equal to I0 square by 2 into R into T. So 1000 is equal to I0 square. I0 square is equal to how much here? Here I0 means here 25 divided by 5. Okay. I0 square, that is equal to 25 by 2 into 4 into T. So T is equal to 2000 divided by 100. 0 cancel. That is equal to 20 seconds. Okay. This is the time. A body is shown vertically upwards, for which graph represents as shown below. This is VT graph. So whenever a body is projected vertically upwards, it moves against gravitational force. Gravitational force is vertically downward, velocity is vertically upwards. So that what happens here, its velocity gradually decreases with respect to time and becomes 0 at maximum height. So if we draw a graph for velocity and time, see this graph, as time increases, velocity decreases at a particular time, the velocity of the body becomes 0. After that, the body again changes direction and it moving in negative direction. Its velocity gradually increases. So the correct graph among the following graph is third one. That is the third one. Okay, now let us discuss another question. A system consists of two isolated conducting spheres kept at infinite distance. Sphere X has a radius 2r/3 and charge 12 microcoulombs. And a sphere Y has radius r/3 and charge -3 microcoulombs. If switch is closed, then find the charges on X and Y. Whenever switch is closed, what happens here? When switch is closed, the charge is redistributed until their potentials are equal. Right. Now total charge is equal to Q1 plus Q2. That is equal to 12 microcoulomb minus 3 microcoulomb. That is equal to 9 microcoulombs. So when switch is closed, the charge is redistributed until their potentials are equal. Okay, KQ1 by R1 is equal to KQ2 by R2. KK cancel. Okay, Q1 by Q2 is equal to R1 by R2. 2R by 3 divided by R by 3, that is equal to 2 by 1. So the ratio of charges present on these isolated conducting spheres are in the ratio 2:1. Now Q1 is equal to charge on the first sphere 2 by 3 into total charge 6 microcoulombs. Q2 is equal to 1 by 3 into 9, that is equal to 3 microcoulombs. Okay, charge on the first sphere is equal to 6 microcoulombs, charge on the second sphere is equal to 3 microcoulombs. This is the answer.